Hello everyone. In this video, let's discuss about the ambiguous grammar questions in the theory of computation. If you are new to our channel, please subscribe for more engineering related topics. So an ambiguous grammar, if we see about the ambiguous grammar, a grammar is said to be ambiguous if and only if it has more than one parse tree. If you are able to construct more than one parse tree, then we can call that grammar as the ambiguous grammar. So let's see two questions. Therefore, you will be cleared how to solve the ambiguous grammar question in the theory of computation. Now let's consider the first question, that is E producing E plus T, E producing E plus E, E producing E star E, and E producing ID. Because of the left hand side is same, they have wrote in the single line. This can be represented as this like also, but since the left hand side is same, they have wrote like this only, E producing E plus E. Slash means this is the another projection, this is the another projection, like that, three projections. Now what we must do is, using these three projections, we must try to build more than one parse tree. If we build two parse tree also, then we can call it as the ambiguous grammar. Now let's try. First, I will be considering this equation or this projection. So E producing E plus E. Next, I will be considering this one. Wherever E is there, you apply E star E. So you can apply to one E only. You can apply to either this E or this E. So let me apply to this E. So E star E. Now last equation means E will be replaced using ID. Wherever E is in the leaf land, wherever E is in the leaf means ending, you must write it using the ID. Now we constructed the tree. So this is the first parse tree. If you parse from left to right, check out the leaf node, ID plus ID star ID. What is my string? ID plus ID star ID. So this is my first parse tree. So I will try to build in another parse tree. So here I will be using this equation or this projection first. So E producing E star E. Now I am completed with this. I will be using this production. So for the same E which you branched, for that one only you must branch. So E plus E, E plus E. Now replace E using the ID in the leaf side. ID, ID, ID. Now again you traverse from left to right using the leaf node. ID star ID plus ID. So what is my string? ID star ID plus ID. So if you see both of the strings, they are different. That means we are succeeded in constructing more than one parse tree. That is, we constructed two parse tree. Therefore, we can call this grammar as the grammar is ambiguous. The given grammar is ambiguous. Next, let's see for the second question. So what is my second question? S producing AS BS, S producing BS AS, S producing epsilon. So I told why I wrote like this, because the left hand side is same, so they have wrote in the single line itself. These are the three separate projections, so I represented separately. Now using this, I must try to construct more than one parse tree so that I can conclude that the grammar is ambiguous. So first I will be using ASBS. S producing A, S, B, S. If you see, S is the capital letter. You are only allowed to expand the capital letters only. Here small a is there, small b is there. You are not allowed to expand small letters. You are only allowed to expand the capital letters only. So here S is there, I will be using this projection. So you can take this S or this S. So I will be selecting this S. B, S, A, S. Now for S you must replace it using the epsilon. So epsilon, epsilon and epsilon. Now traverse from left to right. using the leaf node. A epsilon B epsilon A epsilon. What is my string? So my string is A epsilon B epsilon A and epsilon. You must traverse only the leaf node. Now this is my one parse tree. I will be trying to find the another parse tree. Therefore we can conclude it as the ambiguous grammar. So yes, producing. First time I took this one. So now I will take this projection. So B S A S. In the previous tree, which S you expanded, that one only you must expand. You can't expand the small letters, only big letters you can expand. So now I will consider this projection. A S B S. Now S will be replaced using the epsilons. Epsilon and epsilon. Now again you traverse from the left side towards the right side using the leaf node. B epsilon A epsilon B epsilon. So what is my string? B epsilon A epsilon B epsilon. If you compare both of them, both are different. That is, both strings are different. Therefore we have constructed the two different parse tree. So now we can call this given grammar as this grammar is ambiguous. So the final ultimate goal is to try to construct more than one parse tree. That is, if you construct two parse trees also, you can conclude the given grammar as the ambiguous grammar. And while expanding, what you must do, which capital letter you expanded. Here I expanded this E. So in the next parse tree also I will be expanding this E only. And here we traversed from the left hand side towards the right hand side. Here also we must traverse from left hand side towards the left hand side towards the right hand side using the leaf nodes. So leaf nodes means they will be not having any child. Here ID, star, ID, that like. And you can only expand the capital letters. You can't expand the small letters or the operators. What are operators? Plus, subtraction, minus will be there. No, you can't expand the operators or the small letters. You can only expand the capital letters. My ultimate goal should be of trying to construct more than one parse tree so that I can conclude the given grammar as the ambiguous grammar. Hope you understood the concept of the ambiguous grammar. If you have any doubt, please comment below. I will try to solve it. And if you liked the video, please subscribe so that it will motivate us to make more engineering concept like this. So thank you.